Git is the version control system that powers nearly every software project on Earth. But most developers only scratch the surface of what it actually does. Today, we're going inside Git, the tool that changed software development forever. Imagine you're working on a document. You save it as FINAL.doc, then final_v2.doc, then final_doc. Sound familiar? Now imagine 10 developers doing this simultaneously on the same codebase. Files everywhere. No one knows what's current. Changes get lost. Teammates overwrite each other's work. That's chaos. Git is the solution. Git tracks every single change. Who made it, when they made it, and why. It's your codebase's complete time machine. Git has 3 main areas. First, the working directory. This is your local folder where you actually edit files. Second, the staging area, also called the index. This is where you carefully select exactly which changes to include in your next snapshot. Third, the repository, your permanent, complete history of every snapshot ever taken. Think of it like packing for a trip. Your bedroom is the working directory. Everything's spread out, in progress. Your suitcase is the staging area. You're deliberately choosing what to pack. And the storage room back home is the repository. Everything that's been permanently stored, safely archived, forever accessible. A commit is not just a copy of your files. Git takes a snapshot. It captures the entire state of your project at one exact moment in time. Here's the clever part. Git uses something called content addressable storage. Every piece of data, every file, every folder, gets run through a SHA-1 hashing algorithm. The result is a unique 40-character fingerprint. If the content changes even by one single character, the hash completely changes. This means Git can instantly tell if anything has been modified. And every commit gets its own unique hash, a permanent identifier you can always reference, share, or revert to. Branching is Git's superpower. A branch is just a lightweight pointer to a specific commit. Creating a new branch costs essentially nothing. It's just 41 bytes written to a file in your .git folder. When you create a feature branch, Git is not copying your entire codebase. It is just creating a new pointer that starts pointing at the same commit you're currently on. As you make new commits on your feature branch, the pointer moves forward automatically. Your main branch stays exactly where it was. 2 parallel realities of your codebase, coexisting perfectly, until you decide to bring them back together. When your feature is complete, you merge it back. Git finds the common ancestor, the last commit that both branches shared. Then it takes the changes from your feature branch, takes the changes from the main branch, and intelligently combines them. This is a 3-way merge. If there's no conflict, it's completely automatic. Now, rebasing is a different strategy. Instead of creating a merge commit that joins 2 branches, rebasing replays your commits on top of the latest version of the target branch. The result is a perfectly linear, clean history as if you'd written everything sequentially from the start. Both merge and rebase have their place. Merge preserves history. Rebase creates clarity. A remote repository is simply another copy of your repo, usually living on a server somewhere. When you run git push, you are uploading your local commits to that server. When you run git pull, you're downloading their commits to your machine. GitHub, GitLab, Bitbucket. These are just services that host Git repositories on servers with a friendly web interface on top. The actual version control logic? That's all Git, running the same way it does on your laptop. The magic lies in the transfer protocol. Git efficiently compresses and transmits only the objects the remote doesn't already have, making pushes and pulls fast, even for large projects. Let's go inside the .git folder, the hidden directory at the root of every Git repository. Everything Git knows is stored here as plain files. The objects folder contains every commit, tree, and blob, stored by their hash, a pure content address database. The refs folder holds your branches and tags, each one just a file containing a commit hash. The head file tells Git which branch you're currently on. The index file is the staging area. It's a binary file that tracks what you've run Git add-on. Git isn't magic. It's an incredibly elegant file system with a version control interface built on top. Once you understand this, everything about Git makes perfect sense. Git is simple in concept but breathtaking in execution. A snapshot system built on content addressable storage. Branches that cost nothing. Merging that reasons about history. A distributed architecture with no single point of failure. Once you understand what Git actually does under the hood, once you see it as an elegant file system rather than a confusing black box, it stops being scary and starts being beautiful. The next time you run git commit, remember, you're not just saving a file. You're creating an immutable node in a directed acyclic graph, cryptographically linked to everything that came before it. That's the power of Git.